Hello and welcome to StudyIQ. I am your friend Rahul Saigaonker. The agenda for today's discussion is quite intriguing. It's connected to science and technology. When I heard about the topic, it piqued my interest indeed. The topic of today's discussion is Foucault's Pendulum. I'm quite sure you must have heard about this news. But I'll also understand if you have missed this news. Why? Because of two reasons. First, there is IPL hangover. You can see here the orange cap, purple cap. People are still reeling in the victory of Chennai Super Kings. And the second reason is this news is connected to the inauguration of new parliament building. And we all know the new parliament building was inaugurated recently, and the entire focus or the limelight was on the Sengol. I'm quite sure you must have seen the Sengol installation ceremony, which was broadcasted on many news channels. But along with that Sengol, which represented the transition of power from British to India, another scientific setup was installed in the new parliament building, and that is Foucault's pendulum. And we are going to understand what is that system in this particular video. You will have a question. So is this really relevant from UPSC civil services perspective? I would say yes. May not be highly relevant from mains point of view, but many questions, MCQs, can be set up in and around the concept of Foucault's pendulum. So in this video lecture, we'll understand what is Foucault's pendulum, what is the history of Foucault's pendulum, and what is its importance, why it has been installed in our new parliament building, what does it signify. So you'll get a lot of interesting information to get to know all that. Be with me till the very end. Let's begin. But before that, it's the ultimate day, that is 31st May, the last day to get yourself enrolled for batch 6 or batch 7, morning batch or evening batch, because the admissions are closing for the prelims to interview batch. You do know this is the most comprehensive batch where you'll get all the features. There is preparation for prelims, mains, interview, current affairs program, mains answer writing program, prelims test series. The whole shebang is available in this comprehensive setup. And there is also month-end sale going on. If you use my code Rahul Live, you will get additional discount on this price also. So do it. You just have a few hours. I'll see you in the class. Right. Let's begin our discussion. As I told you, the news is that recently Prime Minister Narendra Modi inaugurated the new parliament building, and we all saw the ceremony. The focus, as I told you, it was on the historical Sengol, right? Sengol, a scepter that represented the transition of power from British to India. It was installed in the Lok Sabha hall beside the speaker's chair. We saw the ceremony. But along with this Sengol, there is something else installed in the new parliament building, and that is the Foucault's pendulum. So what is this? Why this has been installed? We'll try to understand. But Foucault's pendulum, that means this is a name of the scientist, name of the inventor, and then pendulum. We all know what is a pendulum. We all know what's a pendulum, right? We have discussed this during our 6th and 7th interaction also. Pendulum, you simply take a bob, tie a thread to it, it becomes a pendulum. Now, can I see something of a pendulum here? I do have a spare mouse, right? Now this can act as a pendulum, right? This is a pendulum. There is a swing and there is a bob, right? Now, when I give a push to this particular bob, it is going to oscillate. We have seen this. It basically runs into oscillatory motion. This is the basic motion of a pendulum. A simple mouse, right? That I already have here. So a weight suspended by a freely swinging thread or a freely swinging string, it becomes your pendulum. And if I give it a push, you already know there is a position of equilibrium. And if you push it, the bob will move to one side, point A, and then the bob will move to the other side, point B. It is going to oscillate between these 2 points continuously, right? This is the basic kind of pendulum. Now, magnify this pendulum to a large extent, you are going to get Foucault's pendulum. So what is this Foucault's pendulum? Foucault's pendulum is nothing but a normal pendulum, but a relatively large mass and a relatively long line. Why do I create this? And let me just take the mouse again so that you understand. This is a simple pendulum, and when I give a push to this, then it is going to oscillate in one particular direction from point A to point B. But imagine if the string of this particular pendulum and the bob of this pendulum is extremely long. That means it can swing in one direction, it can also swing in a plane. And since the load is heavy and the string is very long, it is going to oscillate very, very slow. Now the question is, why Foucault's pendulum? What was the need of this? There was a scientist, right? There was a scientist in France, Jean-Bernard Léon Foucault. Now, please remember, this Foucault is different from the Foucault that you study in your political science and international relations. That's Michel Foucault, right? That's Michel Foucault or Michel Foucault. He gave the theory of knowledge is power, right? His theory is about power, that power pervades everywhere in the society. This Foucault is different. This Foucault is Jean-Bernard Léon Foucault. Now, what he did was he wanted to demonstrate that Earth is round. There was a belief system during the medieval times that Earth was flat. At one point, there would be an edge and you're going to fall off the edge. But many scientists, they tried to prove that Earth was round, and Foucault was one of them. Now, what he did was he assembled people in the Hall of Paris and he created a huge pendulum. And this pendulum, the bob weighed about 28 kg. And the string itself, you can see the string itself was very long. It was about 67 meters. And in the hall, he started the pendulum. That means he gave a push to the pendulum. And the people who are watching, they watched the pendulum for long, for 1 hour, for 2 hours, for 3 hours. And they saw that the pendulum, which was moving in one particular direction, this direction, it slowly and steadily started to change its line of motion. The center would be same. It started to change its line of motion. Now, this showed that Earth was revolving on its own axis, or Earth was rotating on its own axis. We know that, first of all, Earth revolves around the sun, yes, and Earth also rotates around its own axis, correct? So, this was proved that Earth has a spin on its own axis. All right? Now, you must be thinking, sir, how is this possible? What is happening here? I'm not understanding this. This Foucault's pendulum, I need to understand its principle, what is happening. Now, to understand Foucault's principle, we again need to go back to Isaac Newton, the dreaded Newton and Newtonian laws. They do not leave you from your school till your graduation. Throughout your life, they'll be there with you, right? First law. What does first law, Newton's law of motion, say? That every body continues to be in state of rest or of uniform motion in a straight line unless it is compelled by an external force to act otherwise. That means if I keep this pen at one place, it will remain at rest until unless I pick it up. That means forces have to act either to take a body out of rest or to stop it, to stop its motion. The second law says the rate of change of momentum is directly proportional to the force applied, and it takes place in the direction of force. It basically lays the ground for force. F is equal to mass into acceleration. The third law, my favorite, for every action there is equal and opposite reaction. And this concept of Foucault's pendulum is based on the first law. Now, what does the first law say? The first law says that according to this, I'll take up the concept of pendulum, and if I give a swing to the pendulum, and the first law says if I put this in motion and if no force is acting on it, then the pendulum should constantly oscillate in just one straight line or one direction when I look it from the upper view. So it will come to this point, it will go to this point and continuously along the straight line. What happened in Foucault's pendulum experiment? In Foucault's pendulum experiment, the pendulum, when it was set into swing, of course, it was pulled and pushed in both the direction from point A to point B, yes, but pendulum was swinging and people were watching that the pendulum, now it was swinging here from point E to point B. After 1 hour, after some time, 1 or 2 hours, few hours, it started to move in another direction. But why? Because the Earth was also rotating on its own axis. That means if you just look at this, people are standing here and they're watching that right now the bob or the pendulum is slowly and steadily oscillating in one direction or in one plane, but slowly the direction is changing and everybody was surprised. Why is this happening? This was because of the rotation of the Earth on its own axis, or Earth's spin on its own axis. Now, if you are still thinking what is happening, see, imagine this is Earth, right? This is Earth. We all know this is equator and Earth revolves in this particular direction, west to east. And if I put a pendulum somewhere here, you'll understand exactly on the North Pole, the pendulum is oscillating. But you do know the Earth is also revolving or rotating on its own axis. So the motion of the pendulum, it is going to create a circle like this. And what Foucault's pendulum proves? Foucault's pendulum proves that as I move from the poles towards the equator on either side, I will see the time period is going to increase continuously. Why? Because Foucault's pendulum and its time period, it depends on the latitude or the position in which the pendulum is swinging. Very important from exam perspective. Please remember MCQ, it is connected to the first law of Newton's law of motion. And remember that at the North Pole, if I take a pendulum and if I take a Foucault's pendulum and it is oscillating, it is going to exactly create a circle, because approximately in 24 hours, it is going to create a clockwise circle. That means a Foucault's pendulum is always going to rotate clockwise in the northern hemisphere, and it is going to slow down because the larger the latitude, or I would say the lower the latitude, the bigger the circle of rotation of that particular pendulum. And that is why we see that its rate or its time period, it becomes more and more, or it slows down more and more as we approach the equator. And at the equator, there is no rotation, there is only oscillation at one particular place. And the same in the opposite direction, or at the southern hemisphere, it rotates in a counterclockwise way. Did you understand everything? I'm quite sure there are certain doubts. Let me put it in a more clear way. Now let me explain it with one particular idea. So this is Earth. Now when I traverse the path of the pendulum, this is the pendulum at the North Pole. This is the position in the equilibrium. And imagine this is one position, point A. This is another position, point B. Now what am I going to do? I am going to create what? A cone. I'm going to create a cone. Imagine the pendulum movement can be drawn into a cone. Now this is what happens at the northern pole. That means at the northern pole, since the Earth is revolving on its own axis, as the pendulum is swinging, the path of this pendulum, it basically traverses or creates some sort of a circle. So if I am an observer from somewhere here, right? I'm an observer from somewhere here. What it looks like is as if the pendulum is slowly and steadily revolving in a clockwise way. Now imagine the same thing happening if this is Mother Earth, and as I draw the bigger cones, you'll see that as the latitude is reducing, or as the latitude is I'm reaching towards the equator, then the circle becomes bigger and bigger. That's why the time period, if I get into the physics of this, you'll get an equation that time period of this pendulum would basically be the time period of a revolution of Earth. That means approximately 24 hours divided by sine theta, and this theta is nothing but the latitude on which it is revolving, not the longitude. Please remember, Foucault's pendulum does not depend on the longitude. It only depends on the latitude at which place it is oscillating. Clear? Now, if you're not able to still visualize it, let me just show you what exactly happens. Because this is the setup that we have installed in the Parliament. This is the Parliament's Foucault pendulum. You cannot see the top of the string, but through a string I have connected something here, a bob, and this bob is continuously oscillating. Right? Now let me show you what is happening here. Just observe this particular picture. Observe this picture. This is the equator, and at the equator there is only one particular path of this pendulum. But at any place apart from the equator, just observe the path that the pendulum is following vis-a-vis or relative to the rotation of Earth on its own axis. I hope now you get the idea of what Foucault's pendulum is. Correct? We understood the entire concept. The intention behind this topic was also to explain you how you are supposed to prepare any topic from current affairs. You need to prepare it in a more comprehensive way. You need to understand all its dimensions. What we understood its history, why it was created. We also understood the working principle behind it, because many a times there can be questions based on working principle or a statement based on working principle. I hope now it's clear. Now you can imagine better. The next question, so why was it installed? What was the need of it? Why expenditure, right? Why expenditure on this? See, this was more of a symbolic scientific setup that was installed in our Parliament. This was a symbol of integration of the idea of India with the cosmos or the universe. We know in the cosmos or universe, Earth is a very small speck, and we simply wanted to show it in a symbolic way. Apart from that, apart from that, in our constitution, we already have Article 51A, fundamental duties, which talks about every citizen, they need to develop scientific temper. So we will understand more and more. Now, next time when you visit the Parliament building, do watch the Foucault's pendulum and try to understand what exactly is happening and its importance. I told you, imagine in 1800s, a person trying to explain that Earth is revolving on its own axis and creating an experiment, because it helped us understand that Earth is rotating or Earth is spinning on its own axis, because of which we know so many things. For example, this is also called Foucault effect, or we have read in geography Coriolis effect, right? Because of Coriolis effect, we see cyclones. We do not see cyclones at the equator. We see cyclones in the tropical zone or in the temperate zone, also subtropical zones. Why? Because there is Coriolis force present. Again, because of the rotation of the Earth. This is proved, right? And this particular setup, the Foucault pendulum that has been installed in the Parliament building, it was created by the National Council of Science Museum, and they have installed it recently. And it's a huge stuff, right? It's a huge stuff, because this is the largest Foucault pendulum in India. There is one more smallest available in Pune Scientific Institute, but this is the largest Foucault pendulum that is now available in India. All the components of this pendulum have been manufactured or prepared in our country. The pendulum is made basically from gunmetal, and it has been fixed with an electromagnetic coil also. The bob of this pendulum, it weighs approximately 36 kg, and the length is about 22 meters in height. Imagine Foucault, what he did in 18th century, it was way larger, not in terms of weight per se, but at least the length of the string was long. It's 22 meters, 36 kg weight. And also remember, there are electromagnetic coils and continuous power supply which has been provided so that the pendulum doesn't stop. Now you do understand why this has been given, right? Because we all know that, I told you, Newton's first law. If I start the pendulum, then the pendulum, is it going to swing perpetually? No. Then it will become a perpetual machine. We already know there are a lot of forces acting on it. The force of gravity, most importantly, the friction from air. And because of this friction, you already know that once I start this bob, or once I start the pendulum, eventually at one point of time, it is going to stop. And I don't want that to stop. Imagine I go to Parliament to watch this spectacle of Foucault's pendulum and it stops. And that is why the electromagnetic coils and power supply has been provided, and a continuous kick is given to the pendulum for every oscillation so that it reaches to these points. Now I'll just show you, if you see this particular image, you'll understand that the bob is going to reach to this place and this place, and this distance is going to be constant, because of which there is electrical supply, electrical coils which are connected to it. All right. Now, as I told you, it's not the first Foucault pendulum. Foucault pendulum have been installed in many other places. In India, this one is the largest, which is symbolic. In many places, for example, in Vancouver, Montreal, which are at different latitudes, Foucault pendulums have been installed, and at different places, the pendulum takes time, or pendulum takes time to complete one particular circle or one particular clockwise rotation in the northern hemisphere. Now, at the Parliament building, it takes approximately 49 hours, 59 minutes, and 18 seconds to complete one rotation. That means we can see India would come somewhere here. If I draw a cone, then this would be the latitude approximately where it is going to complete one rotation in about 49 hours, almost 50 hours. The original Foucault pendulum, which was set up in Paris to prove or to show the results of the experiment, it rotated one circle or one rotation in about 32 hours. All right. So this is the history of Foucault pendulum. When you visit to the Parliament, do go there, do watch it, and try to study, right? Develop your scientific temper. That's why I told you, when I was reading this topic, it actually piqued my interest. I was reading it, and it's a very wonderful experience. Some historical experiment now in my Parliament building also. All right. I hope you have gotten all the nuances or all nitty-gritties connected to Foucault's pendulum. If there is any question on this, do not miss out. Do not commit any mistakes. That's the end of the discussion. And if you have liked this discussion, you can always follow me on my social media handle @Rahul Sai 222. If you have any queries, concerns, complaint, feedback, questions, whatever it is, if you want to connect with me, directly message me on IG. I do respond on Saturdays and Sundays. Thank you for watching this video. Jai Hind.